Hello, everyone. So welcome to this webinar about this part is Mopo about the INES for interoperability data transfer and the latest features in SpineOpt during the Mopo project. Thank you everyone for attending. So I think we're gonna give one more minute to see if someone else joins, and then if not, we can start with the first part that is led by Arttu. Yeah. Is the recording? Yeah, it's the recording transcription. Okay.
Yeah. Well, because we are splitting this in half, so it's probably like 20 minutes and then questions and 20 minutes and questions.
Yeah, exactly.
Or something like that.
Yeah, that sounds good. So yeah, so let's take the most of it. So I think we can start. So Arttu, the floor is yours.
Yeah. So yeah, I hope this is fine. I will be jumping back and forth from this PowerPoint, so that's why it's not in the presenter mode. So I'm Arttu Tupala. I work for PTT, and I'm going to talk about the INES stuff. So it's made for interoperability between tools. So let's start. First, about the motivation for this work is that there are a lot of tools for any system modeling. Here in the background is a AI generated list. I don't know what how those tools are, neither do you, and that's kind of the problem. There are so many tools. They are old and new. Some of are made for different scopes, scales, purposes, but they are not like all exactly doing the same thing. So there are opportunities for interoperability between those tools. So what is in a spec? Why should we use this kind of specification in between? So specification means that it's just a kind of format and structure to present this energy system data. The big reason is that, of course, you can do connections between tools one by one, but then you are only getting the one connection between the two tools. But once you have the specification, you actually connect your tool to all the other tools that also use the specification. So that's kind of the big idea. And then, of course, why? What can you do with this kind of specification? The simple thing is that you can use this to transfer model instances to different models. You might want to build upon an old model of one tool or validate some results or something like that. But then you can also do model couplings, which is a more interesting option, that you can have two different tools doing similar things, but they have different differences between tools and their purposes. They might be doing stuff in different scales. Some tool might be like a European-wide scale, and then you do something more specific in like a country level, or then they might be for different purposes, for like combining an investment model and an operational model. Yeah, you can compare them, compare tools, you can test stuff. And of course, one big thing is that sometimes input data is made for different tools, specifically for those tools. There are like data pipelines made for one tool, and they can create these models easily for that one tool, but then if you want to use it in different tools, you can kind of transfer and have the ability to use that data pipeline for some other tool. We will have an example of that later. The idea, what we have done in Mopo, is that we have this INES spec in the middle, which holds this, which is the specification for data, and then we want to have transformers between different tools. Of course, SpineOpt has been developed in Spine, but then of course every other possible tool. And of course we also have made these data pipelines that also pass stuff to this interoperable energy system specification. So the input data is in that format as well. But what this also allows is that we can validate these tools. We have a certification process. We have an example of that later, and do stuff like that. So we have one central place that we can have this data format in. Okay, then the hard part, actually explaining what the specification is. So I will show you on the better after this slides what it actually looks like, but some information first. So it's quite abstract. It has to be quite abstract. We don't want to have these. As I said previously, I can use this full slide so if you want, but I will soon go away from it. So it's quite abstract. We don't want to have these tool specific stuff in the specification because then you cannot really transfer it into the other tool. It uses this nodal structure, even though some tools want to pretend that it doesn't exist in their input data, but it's kind of how the optimization is built under anyways. One big point is this is currently in this like energy system level. You can have multisectoral models, but it doesn't have this power system physics, these kind of voltages and that kind of stuff in it yet. We want to add it, but that requires time and people who have knowledge and opinions about that. How should it be created? And it will use kind of these functionality-based methods. I will show you it later. It's probably easier to show, but there is kind of method that tells what kind of unit or how will it use this data, and not just what is the data. I have not much about this slide more than it has these relationships between the entity classes. Oh, sorry. It's easier when I show you. Oh, this is fancy. Main thing here is that one thing that we got from the Spine to this INES specification is the idea of these alternatives. That you can have basically present multiple scenarios within the data, but you present only the differing values with these alternatives. And then it has you can then create the scenarios only choosing what alternatives are used and where. Okay, at this point it's probably easier when I switch from this. Yeah. So looking at the specification itself. Now I'm looking at one bit I forgot to say is that this INES is in different formats. It's not only in the Spine database format, but you can actually see it from there are, for example, it's in JSON, DOM, TTL, and these different kind of formats. But I will now show you stuff mainly for the Spine database version because it has this visualization built in. So yeah, so what we have here is that we have these kind of nodal structure. There are some entities that tell about the structure of them, like temporal structure of the model, and then we have these nodes, links, units without the core. So nodes and then stuff that transfer energy between the nodes. But then we have these, for example, in the node, we have, they can be specialized that, okay, this node is a balance node, is the basic node that, okay, you can have demand here, but then node can be a storage or a commodity. So that's how some more specialized stuff can be presented, even in this structure. And then we have these sets that tell that you can have some parameters for multiple entities or a group of entities. But one big thing that the slide wants to tell you is that we have also have these relationships between the units. So we have a node to unit relationship, and we can have, probably this is better, we can have data for that relationship as well. So not only for the units and nodes, but also the relationships. This is more relevant when because this allows you to have these units that have multiple outputs or multiple inputs, and then you can have specified data for that. But this is kind of how the specification looks. The data here is from one Northern European model that has been transferred from Backbone to INES. But yeah. Yeah, one more big thing that there are the descriptions, of course, at how each parameter should be and what kind of data types it handles. But yes, back. Then to data transformers. So actually passing stuff between the different kind of models. So if you are doing it in Spine, that most of the transformer has been made, there is a Python package that helps with. Of course, there is an API to handle the Spine database. So there's an API, but then there's also some data processing tools that we have created that makes it like simple transformations easier. So you're basically just putting stuff on a YAML file, and then you don't have to write code. Yes. But yeah, the big point even that I want to emphasize, not everything has to be done through the Spine databases. Currently, we have these transformers. So we have Backbone as the most pipes are coming in, and Flexel and SpineOpt out. I think there's some work still on Empire, and I think Tupala. I don't know about that much, but I see that repository exists. The big problem here is that the tools are only in one side. They should be on both sides, but that's a money and time problem mostly. And as said in the previous, on the first slide, is that the usefulness of the INES depends, or any kind of specification depends a lot on how many of these transformers exist. Because the idea is that when you connect one tool to the INES, then you get everything that is connected. So the big thing is to add stuff, add these transformers here, and preferably on both sides. And of course, to remind you that the data pipelines exist. Should I now show you? Well, I'll show you the certification process first, and then I will go through the transformers. I will have examples on those. Then we have a certification process, which the idea is that we have some models. The idea is to be able to certify that the models work correctly. That's the main idea of the certification process. But how it works is that we have a repository of these kind of simple models that test a specific feature of the tools. And then how it works is we transform the data through the INES or from the INES to the model, and then we run the model, and then we check it with like a hard-coded jump code and see that the results match. We have done this for SpineOpt, and it works now. Yeah, I can first show an example of this, but yeah, there are 10 systems for the certification, or small. There are all these kind of really small systems that, for example, this is just to test that, okay, does your investments work correctly? This what you see on the right-hand side. I can actually now show you again. How does it look? Here they have been all connected to this in a SpineOpt, but you don't have to do that. Probably first I can show you how does it look. So the certify just includes always a JSON file, which is just the INES version of the problem, and then this Julia file, which is just a short jump code that produces the same problem, but it's kind of directly made. And these can be either run separately or put on Spine Toolbox. Here we have this certification database. I put there, or I can quickly delete everything, and then I can put stuff there. So this is not that way. I want to import because it's a JSON. Import this, and it creates it in the Spine database, and then we can run these both. I've done it now before, so we don't have to waste time on that. And so we can run it through to SpineOpt, and then run the SpineOpt and see the results. And then we can run it. There. But yeah, we can run this Julia file directly that I showed you. This one, and then just compare the results. So these are so small models that it's usually enough to just look at the objective function value. It's not really possible to have something broken there and not showing in results. The only exception is the 10th model, which combines all these 9 other tests together to see that does something break when you combine stuff. That's the only one that you might have to look some deeper than just the optimal value, but this is the value here. And if we look at that we have run in SpineOpt, the objective value is the same, so it works. Storage is at least working in both in SpineOpt and then SpineOpt. Yes. One big thing that I forgot to mention is that it doesn't only test that the tool works, but it's actually very useful for testing that the transformer works as well. So when we are making transformers, it's kind of useful to try to then run these tests, these certification tests because that will tell you if you have problems in the transformer as well. Yeah, then to the actual transformer examples or use examples. This is what I like to call the motivation slide for you. So this is an example for where we have basically used the pipes earth data and pass it to for another model. So it's just you have done the whatever the pipes earth pipeline works. It has created a pipes model. Then you can pass the pipes model to a different model here, Flex tool, and then run it in Flex tool. I made a kind of simple case study that tests this. So it kind of works. And if you want to use your tool, some other tool, you can do the same thing if you just connect your tool to INES. And then this is the fancier coupling of two tools, where we have coupled osmosis and flex tool, so that the osmosis does the investments, and then flex tool does the operation or checks the operation, because osmosis is a time slice model. And it is a fancy coupled model so that it runs the osmosis back, then creates the flex tool input from the osmosis input. So you don't have to create two different inputs. So it just automatically creates it from the osmosis, and then it also passes the osmosis results to the flex tool as well. And this if you go there, it's also made so that you only need to kind of download two zip files and extract them. So it might look kind of scary when we have this mass of different Git repos, and then you kind of have to look at different installations, but you can always manage to package them so that you can just have zip files. Here is the list of all the. We have this GitHub INES tool where everything is under it. So we have the data pipelines and certification and INES tools, and then this big list of different kind of tools that have been connected or have been tried to be connected to INES. One thing that you might have wondered is why Flex tool, because the SpineOpt INES to SpineOpt was just made, and actually I was promised that tomorrow the SpineOpt will be merged so that the new data structure will be there, so that because the INES SpineOpt has been made for the new data structure, so that will work on SpineOpt for all, that you don't have to go searching for branches. And yeah, the last slide that I have is that if you want to add new transformers, the best tip that I can have for you is that use the previously done transformers as examples. There's so much stuff there. Also that using the data processing tools that also simplify making the transformers. But right now, just use AI. It will help a lot, but it won't do everything for you. I tried while making the SpineOpt transformer. It won't do everything. But if you want the tips on that, so just feed some previous transformers as context, the processing tool file, and the specification of the other tool, and then a lot of documentation. And how far you will get, it depends a lot from the specific the documentation, how thorough it is. Does it just say that this is a parameter, or does it say how is it actually used? Because there will be problems that you will have to deal with, because the documentation is not as good as you want. And I would also need to go and improve the INES documentation part as well, specific for AI, to explain more detail how each parameter works. But okay, I've extended my time almost, so yeah. Do you have any questions? Great silence.
Great. I think in any case, if someone, yeah, there is a question now. Great. Let me just see if I can switch on the mic. Or can you put your mic maybe?
Sure. Yeah. Thanks, guys. My name's Padraig Daly. I work in SEI. It's the Energy Authority in Ireland. Thanks for your work. It's great. Like we've universities in Ireland that use the Times modeling framework. So there's definitely, definitely it's great that this will make collaboration easier between different platforms. I was wondering, would you think about transforming data across different model types, like from investment and unit commitment to load flow in the future, or is that completely out of scope for this type of specification?
I mean, it's not completely out of scope, but it's time and money problem. I have a slide somewhere on this great vision that would be the idea to have these kind of different kind of models, add more kind of stuff, but that's a lot of work, but it's also like I would need kind of expertise on those kind of models added to this kind of work, because I'm not an expert on every kind of model, especially when go to this kind of load flow models. That will require other kind of people who have more experience on that. But that's the idea and future plans. But yes, it's always a money and time problem.
Yeah, understood. And if someone's, let's say, coming from proprietary tool background and they're thinking about moving open source, where would you recommend to start? Like if you're going to go with Spine or pipes or whatever, do you recommend to start there, and then once you're an expert in that domain database, do you then go and learn INES, or should one go to INES first off and try build generalized models that then shove into that software?
I mean, no, just first learn a tool, because you cannot actually, it's first learn some tool, see how they actually work, and then, because INES is just like a passing data around, so you will first have to like kind of understand some tool, how they work, and then you can pass data around.
Sure. Yeah. Thanks very much.
Yeah, I will say that that's the best way. If you have your tool, you know the parameters, you know how it works, then start with INES and then start doing this matching of things that things are familiar for you. Great. Any other question or comment? Good. So thank you, Arttu. I'm gonna just maybe start with the second part. But in any case, if someone has another question for Arttu at the end, we can also spare some time from the other part. Okay. So let me just share my screen now. I think, yeah. Can check here. I'm then start. All right. So this second part is about the latest features in SpineOpt. Basically, I'm gonna tell you about it, how more or less they were implemented, a little bit of the feature and some details about how it was implemented in SpineOpt. Plus, I'm gonna point you out to the tutorials, which I mean, for the sake of time, I don't have time to go through the tutorials, but ideally you can go and you can follow a tutorial using a SpineOpt, and then if you have some feedback on those, that would be nice. So first of all, we want to talk about the multi-year investment, also known as pathway planning. I think those are the two most common names in the energy community, but maybe someone has another one, but those are the two ones that I have seen the most. So the first thing that I wanted to mention is, okay, before this project, before the Mopo project, what we had there in Spine as tool. So basically, we only had, so this is before version 0.9, just to make a reference. What do I mean with before the Mopo project? So there was only one investment block. So that was, let's say, kind of flexible in the sense that you were able, that investment block could represent a single year or multiple years, but it was only one investment block. So for example, if you wanted to have a investment block of 10 years, then and then you wanted to have like a yearly duration, then it means that it was 10 years, consecutive years that you needed to solve, both in investment and in operation. So if you wanted to model, let's say, until year 2050, that implied that you needed to do some kind of assumptions, especially in the operation part. So it was possible to do multi-year investment, but it had some. I mean, it could have, at that time, was really computationally expensive. Nevertheless, there were things there that are pretty cool, that are really interesting to have for this type of models, like the mode polling decision variables, the decommission variables, and of course, to have a good representation, also the fixed operation and maintenance costs. Also, those things were there and are still there. So there was a good starting. And also, when we were having multiple years, let's say there were no discounted factors included in that at that point. So this is where we started. And then during the project, basically we focus on this economical and technical representation of investments for multiple years. There is a document for KU Leuven that was the base of this work. Which also is fair to mention that it was at the end of the previous European project. So we took that as a starting point in this in the Mopo project to continue developing that feature. So there is the link. So you can, later we share the slide, so you can go and see all the details. But basically, what it means is that, of course, you have different periods. Do you want to invest? And then what you would like to have is, as I said, if you want to go until 2050, sometimes it's difficult saying that I'm going to solve yearly. It's too computationally expensive and also data intensive. So you would like to have some milestone years, 2030, 2035, 2040, 45, 2050, or even less granular. So you have these red periods, these red years that are going to be your milestone years. So the years where you want to represent the investments. So that's the basic rationale. Other things that are interesting is that, of course, you want to have discounted periods or a discounted year. So basically, in this, when you start using these multiple years, you want to say, okay, I want to have a reference. For example, all my investments are referred to dollars, euros, whatever you want, whatever currency of 2015 or 2020 or whatever. So you would like to have that those costs of those investments are then discounted to this reference year. So that's also important to consider in this when you are going to multi-year investments. More things. So you would like to then, of course, start accounting for annuities. And these annuities, there are also a couple of things that are interesting when you are analyzing multi-year investments. It's this, for example, lead time period, where you are saying, okay, I'm starting operating this investment in this year one, but then of course there has been some investments in previous years. So here, and also I can say, okay, there are some so a reduction in the investment until the let's say this investment is out of phase. So, and also you want to have like every year, what is the equivalent, the annuity of that investment. So you want to introduce those kind of markups that help you to calculate this distribution of the investment. So you have the overnight investment, and then you can do this, you can calculate these markups. And this is through the economical lifetime. One thing that is important to mention is that here at the year one, we assume that the investment, it's the decision variable is when the investment is starting to operate. So this part of the lead time plays a role in the objective function, but not in the operation. So in the objective function, these costs are going to be accounted with the corresponding years and everything. But let's say for the operation, the investment variable represents when the unit is going to start working in or operating in the system. Good. So other calculations that you need to take into account when you go for this multi-year investment mentality is that sometimes you need to add something called the salvage value, which basically this salvage value represents that you have, for example, investment that the lifetime is 20 years. And then let's say that investment is, and you are also only optimizing to 2050, and then you invest in 2040. So let's say you are only accounting for 10 years of operation in your model, but then you have 10 years that you need to do something because the overnight investment was for 20 years. So this salvage value is a way to account for the remaining cost that is not included in your optimization horizon. So that's something that also needs to be taken into account when you are doing this type of multi-year investments. And in addition, you can also have technology-specific discounting rates. That's sometimes quite useful to allow, okay, for some specific technologies or for generators or units or connections or whatever you want, you can have a specific discount rate to kind of model some more risky investments or some kind of appetite, let's say, for different for these investments of these particular technologies. And in addition, you need to do this discounting the fixed operation and maintenance cost. As I mentioned, this needs to be done to the year that you do the investment. So as is shown here, all those years where you have these milestone years, you need to account for the fixed cost related to the year of your investment. So also that's a tricky calculation that you need to do, easy, but you need to be careful. And also, in addition, you need to discount the operational cost, meaning that, of course, if you have a milestone year one, then this is representing, let's say, 4 or 5 years. So you need to account for those years into the milestone year, and then the second year, the other ones. So in that sense, you need to always, these years are, let's say, representing the operation of 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 5 for 5, let's say, 5 years in the future. So this milestone year represents 5 years of operation. So this also needs to be discounted and needs to be taken into account in order to be, let's say, or try to be more accurate or representing adequately the economics. So in the new and in a SpineOpt, what we have now is the user-defined parameters. So what you should do, what you should have to define. So that you need to define basic data, like for example, okay, which are the milestone years and the period associated to those milestone years. So when do they start? Where do they end? What is the duration of those, let's say, investment blocks that you want to define as a milestone year? And of course, you can have then now different blocks. You need to define the model horizon. So when this is gonna be a ending. In addition, you will need some economic and technical lifetimes, some lead times for the investment, some discount year, and some discount rates. General one for let's say for the social discount rate, another one specific to the technology if you want. I mean, if not, it's not gonna make any difference. It will be using the general one. And then all those things that I was mentioning you are calculated in SpineOpt, meaning that all this information is the basic input data. And then what you get if you activate this, if you want to work with these calculations, so SpineOpt does that for you. Basically calculates all the discounts factor and also for the investment parameters, calculate the salvage fraction and the different markups, either for the specific technology interest rate or for the annuities that you need to calculate. So all this calculation is done by SpineOpt itself, and this is the input data. So that will allow us to do multi-year investments, and also with these milestone years, it will be more efficient computational-wise. So as I said, I'm not going to enter into the details of each one of the tutorials, but just to encourage you to go there. So there are, in these tutorials, we have basically 3 tutorials. The first one is called Capacity Planning Tutorial. It's in our documentation. So just quickly show you here in our, for example, here, if you go to the documentation of a SpineOpt, you have in the tutorial sections, you have this capacity planning one, and you can go through it. So you can play around and do some changes and see if you want to do some analysis. It's very simple cases, so it's easy to follow. We have also a multi-year investment part 1. So we use these milestone years, but we don't use the economic representation, the calculations that I just showed you. Why we want to do that? Because we wanted to be flexible in SpineOpt, such that let's say, for example, I want to try and be doing some research on how it's going to be the distribution of the annuities. Let's say I want to check what happens if let's say an investor wants to recover at the beginning more and less at the end, which is something that is pretty common in investors. So you can modify the annuities as you wish as in the input data, and then you can analyze your case. But that means that you have your own calculations, and then you give it as an input data to a SpineOpt, and don't allow SpineOpt to do anything else. It's just, okay, SpineOpt, this is the data, don't do any calculation for me. I'm giving you the representation. So that's what we show in this part 1. In part 2 is when we make life easier for you if you want to. And if it's, for example, if you say, okay, I'm okay with the standard equations and formulations that you show, and SpineOpt doing these annuities and all this part is good enough for me. So I don't want to be bothered. I want to give the basic input data and then just allow SpineOpt to do all the internal calculations for me. And that's what we show in the part 2 of this multi-year investment tutorial. So it goes from, let's say, less complex to more complex, but in the end, more or less show what you can do, what you can achieve with the SpineOpt. Good. So that's the first one. The second part, I will leave questions at the end. The second feature that I wanted to show is the seasonal storage with representative periods. So that was also something that was, so first, what are the representative periods? So what I mean for that is that through a year, you can have, let's think about days. So representative periods is because it can be more general, but let's say people is more familiar, or community, the energy community is very familiar with representative days. So what you want to have is that you have through the year different days for different countries, and then you kind of want to leverage the patterns that you can see, and then you can do some kind of clustering such that you can have this representation of the full year into just a couple of days. So that's the basic idea. What we used to have, or what was, let's say, done in SpineOpt before, was something similar to this, in which basically we were saying, okay, we have different periods, and in this case, the days, and then we have some representative days. And then, for example, these 2 days were represented by this day that is a little bit more sunnier. This day that is a little bit cloudy represents, let's say, this day in yellow. And this one that is rainy and more cloudy is represented by this light rain, or yeah. So you were having this. So this was more or less what we used to have before in SpineOpt. As I mentioned before, I meant version 0.9. So that is translated to a mapping. This is the basic weighting mapping. You have only 1-to-1 assignation. So basically, those arrows can be translated into a matrix. What we did is a little bit of something that, this one is to non-seasonal so we can do something here with the non-seasonality. So we can, for example, for the storage, represent batteries can be represented in each one of the days. And this trick or recovering the chronology, we can use this information or this recover chronology with this matrix to get the, let's say, the seasonal long-term storage. So these 2 representations were already there in SpineOpt before the project for, let's say, non-seasonal storage and for long-term storage or seasonal storage. So this trick was there, was working amazing. So what we have done, so basically we have improved this a little bit. We started doing some research also in how to combine different days to have a better representation of this seasonal storage, especially. So what we show, or what we have done, is that, okay, you can have a matrix that has fractional weights, and also a couple of more tricks under the hood, but let's think about fractional weights. And then with these combinations, you can get a better representation of these days that are used in the seasonal storage. So basically, this is part of what we did during the Mopo project, allowing these fractional weights to improve the seasonality. And there is a tutorial right now that is also the tutorial on representative periods. Also very simple. You have a battery, you have a fuel node, couple of plants, and demand for electricity. And in this one is really straightforward. It's just 3 days. One day, day 1 is representative period 1 is day 1, representative period 2 is day 3, and the day 2 is just a linear combination of both, or 0.5 and 0.5 for each one of these, just to make it simple. So the main things that you need to consider when you are working with this is the temporal structure, because you need to define these relationships between these representative periods and the original periods. And also you need to define some specific parameters for the storage to say to the model, okay, which ones are long-term, so which ones are going to be using the recovered chronology, and which ones are going to use the not going to use that, and only the representative periods information. So I'm running out of time, so going quickly. The battery in that example is long-term storage equals default equals false, meaning that when you solve the model in that tutorial, you will see that you only have data for the first and the last day. You don't have data, you don't have results for this day because it's not represented as a long-term storage. When you do it for the fuel node is basically done as a long-term storage equals true. So basically the trajectory, this blue one, that is represented by these points. Actually, we might want to work better with that in the outputs, but basically these points represent the end state of the storage, and then it goes to the trajectory. So basically takes the delta of this delta of this storage, and then it creates this as a half of the delta in delta of the storage in representative period 1 plus delta in the representative period 2. So basically, this is a simplified version to show how is recovered that seasonality in this case. Some other things that we did during Mopo was this integration with Tulipa clustering, which is another package from another project that allows to have these fractional weights, but also to try to get the clustering that tries to obtain extreme points that are the ones that are interesting for the investment, for example. So that's, I'm going to enter into the details, but just to show that it's something that has been implemented when we combine those two projects in a workflow as the ones that Arttu was showing. So the Spine Toolbox can handle this thing kind of integration. More things that we have done in the latest version. So that first formulation was a little bit slow. So to create this case study was 45 minutes. There were some improvements during the Mopo project, and then we reduced those times. This is another case study, which is from the Mopo project for the European case study. And we implemented this new delta formulation, which is an improvement on top of that is now reducing the time to 3 minutes. And in this case, almost half of it. So that's one of the advantages. Also, we improve not only the representation, but also the efficiency in formulating these problems with seasonal storage. And last but not least, I'm not going to spend that much time, but because there is actually a webinar next week with all the details of this. But the multi-stage optimizations, the basic idea is that you have a base model and you have another stage. And basically what you want is to have interactions from these two stages. So think about, you have first an investment stage, then you want to fix those investments into another stage, which you have the dispatch of the seasonal storage, and then you want to do the hourly dispatch in a rolling horizon mode to get the prices, for example. So let's say in 3 stages. So you can do that through a Spine Toolbox if you want to, but then it means that you need to handle the inputs and the outputs from one model to the other, and then it can be a little bit cumbersome. So this is basically making it easier for the users. So in one database, in one structure, you can do this cascade of linking different versions of the model. So I don't want to go, as I said, there is a webinar specific for this topic next week. So this is just for you to have an idea. So this is more or less how it works. You can nest versions of the model that basically one output of one version of the model, let's say the investment feeds another model that, let's say, for example, the midterm, the medium term planning to dispatch storage, and then you can then those outputs pass it to a rolling horizon hourly dispatch type of model. So this is internally handled, and as I said, there is going to be a specific webinar for this because this is quite useful for modeling. And with that, I'm gonna stop. So in case there are some remaining questions, we have a little bit of couple minutes if someone wants to ask related to these three features. Yeah. Any questions? No questions? All amazing. Great. So if there are no more questions, so okay, thank you. And yeah, so anyway, I encourage you to go to the tutorials. Please play around. If you have any feedback, remember, create an issue, and we will try to fix it if it's something, or at least help you out if it's some kind of indication. It really helps us to have your feedback when you work in the tutorials, because they are easy to trace back and see if something is missing or something that we can improve. So please use the tutorials as a good way to start and also to practice and try all these features. And with that being said, thanks to Arttu. Yeah, and thank you all for coming, and see you in the next one. Bye-bye.